Now we'll see the examples based on a mixture of both Cauchy's integral as well as a generalized Cauchy's integral formula. So here one of the question is evaluate integration of z square minus z plus 1 divided by z minus 2 whole cube dz over the circle C of mod z is equal to 3. So just you observe here, so in the previous class we have seen we didn't had this raised to power 3. So to remember, so in the previous class I had given a generalized Cauchy's integral formula, that is, it is nothing but f raised to n of a is equal to n factorial divided by 2 pi I integration of f of z divided by z minus a raised to n plus 1. So this is generalized formula. So f raised to n is nothing but the given function f of z we have to differentiate n times at a point a, and here if any power this z minus a is a pole, is pole raised to any power is coming, at that time we have to use generalized Cauchy's integral formula. So we'll use this and we'll solve the respective example here. Now, so the given question, that is z square minus z plus 1 upon z minus 2 cube into dz. Here the point means we need to consider this. So z minus 2 is a point. So here the place, this what plate is there, z minus 2, this 2 is nothing but the value of a. So therefore which is also called z is equal to a is equal to 2 lies inside the circle, because this 2 what we have 2 is will come on before what here 3, means I can say if radius is 3, this the value 2 will be out here inside 3. So therefore at that time we can apply a Cauchy integral formula, but here we'll apply Cauchy's generalized Cauchy's because of power 3. Power 3 means we need to apply for a Cauchy's. So by the generalized Cauchy's integral formula, integration of f of z upon z minus a raised to n plus 1 dz. Just I have rearranged this how we required to the problem. So we have to arrange like that and we need to simplify. You just refer the given main generalized formula, rearrange, you will get in this form. So f of z upon z minus a raised to n plus 1 into dz is equal to 2 pi I upon n factorial f raised to n of a. So here the numerator part is nothing but f of z. Here numerator part is f of z. Next, so here we need to see that the n value, so this can be written as 3 can be written as in the form of n plus 1 form. So 3 can be written as what here 2 plus 1 form. So n value what happens here 2 and a value is what here 2. So therefore n is 2 means what here we need to differentiate f of z 2 times. So therefore f dash of z, if how many times n, that many times you have to differentiate. So here n value is 2, so therefore we have to differentiate the f of z as 2 times. So first time differentiation is 2z minus 1 and one more time differentiation is what here 2. So therefore these all values we need to apply in a generalized Cauchy's integral form. So f of z value is z minus z plus 1 divided by z minus a value is 2 raised to n plus 1, that is 2 plus 1 into this. Means once you get finalized, you should see that this and question will be same. So is equal to, as per the right hand side of the Cauchy generalized Cauchy's integral formula, 2 pi I upon 2, n is nothing but 2 here, so 2 factorial. So n is 2, so we'll give in a dash because differentiation this is stand for 2 only. Okay, so if n is 3, we'll put 3 lines. If n is 4, we'll put 4, means 4 time differentiation. If n is 1, 1 time difference, 1 line will put. So f double dash means what here, so it is nothing but n is equal to 2 times the value of a, the value of a is 2. So therefore so we know that our f double dash of z is what here 2. So f double dash of 2 will be again 2. So that's why the value of f double dash of 2 will remains out here 2. So this 2 and 2 get cancelled. Answer is 2 pi I. Next example, evaluate integration of e raised to 2z upon z plus 1 whole square into z minus 2 of dz with the circle mod z is equal to 3. So the given integral, we have to take it as it is. From this you choose the numerator as f of z. So but 1 upon z plus 1 square into z minus 2, we need to separate this by using a partial fraction. So 1 upon z plus 1 square into z minus 2. So this can be written as, this z plus 1 square can be written a upon z plus 1 plus b upon z plus 1 whole square plus c upon z minus 2. So you need to simplify using partial fraction. So if you put z is equal to minus 1 here, so we'll get the b value as minus 1 by 3. Similarly, when you put z is equal to 2, we'll get c value as 1 upon 9, and when you put z is equal to 0, we'll get a is equal to minus 1 upon 9. So therefore, apply the value of a, b, c in the given partial fraction form what we have prepared. So the left hand side as it is, right hand side a value, b value, c value, you have to substitute and rearrange it. And before rearranging, multiply e raised to 2z on both sides, here left hand side, because the given function f of z what we have chosen is, it is e raised to 2z. We need to multiply both the side. So here 1 into e raised to 2z, so left hand side, so minus 1 upon 9 will keep outside into e raised to 2z upon z plus 1, plus into minus is minus, 1 upon 3 times e raised to 2z upon z plus 1 square plus 1 upon 9 into e raised to 2z upon z minus 2. So once we get, we have to integrate, take the integration on both the side. So taking integration both side, will get this formation. So we see that on the right hand side of this equation we have three integrals: first integral, second integral and third integral. So each integral having different pole, different point. Here z plus 1 means the value of a is minus 1. Here z plus 1 means again value of a will be minus 1. Z minus 2 means value of a will be out here 2. So here in the equation 1 the points are, I am writing, so because of the first integral, the value of z, which is also nothing but a, is nothing but minus 1. From the integral number 2, so value of z is again out here, z plus 1 means value of a will be minus 1. And from the integral third one integral, so z value will be out here plus 2. So now first and third, you just see here first and third, we don't have raised to power any here, we don't have raised, but here raised to power 2 is there. So first and third we need to apply Cauchy's integral formula, and for the second one we need to apply generalized Cauchy's integral formula. So first I will solve first integral and the third integral by using Cauchy's integral formula. So Cauchy's integral formula is given by f of z upon z minus a into dz is equal to 2 pi I of f of a. So on simplification, so the first integral, I have taken first integral. What is first integral? Integration of, I will keep minus 1 upon 9 outside only will pick only what here, e raised to 2z upon z plus 1 into dz here. So here we need to apply here, so it will become out here, so z here a value is minus 1, so 2 pi I, a value is out here minus 1. This a value we need to apply in f of z. Our f of z is nothing but e raised to 2z. Replace z is equal to minus 1 here, so it becomes e raised to minus times 1, that is e raised to minus 2. So therefore you replace f of minus 1 as e raised to minus 2, so which can be rewrite as 2 pi I, e raised to minus 2 can be written as 1 upon e raised to 2. Similarly we need to simplify third integral, because third integral can be solved by only a Cauchy's integral. So third integral will be simplified, so replace a is equal to 2, so replace in this 2 in the f of z, so f of 2 will become e raised to 2 into 2, so e raised to 4, so we got third integral result. Now we need to find the value of second integral by using generalized Cauchy's integral formula. So now second integral of equation 1, we need to apply generalized Cauchy's integral formula. So here the formula is f of z upon z minus a raised to n plus 1 into dz 2 pi I upon n factorial f raised to n upon a. So here a is minus 1 and n is 1. So if you compare, because if you see here, so what we have, so raised to 2 can be written as 1 plus 1. So therefore the value of n will be 1 and a is nothing but minus 1. So therefore the left hand side and right hand side 2 pi I upon 1 factorial. So because of n is 1, f dash of a, means the given f of z we have to differentiate only once. So therefore integration of we have to integrate, differentiate 1. So e raised to integration of this will be, you have to rewrite it, but differentiation of f dash of a, that is we have to differentiate f dash of z at once. So differentiation of f dash of z is what here, e raised to 2z into 2, that is 2 times e raised to 2z. So this value you need to apply here that is 2 pi I upon 1 factorial is 1, f dash of minus 1, but we need to find what is f dash of z first, already we have taken. So it is 2 times e raised to 2z. Here we need to apply z as minus 1. So on simplification we will get what here, 2 upon e raised to plus 2. So therefore 2 pi I into 2 upon e raised to 2. So 2 2s are 4 pi I upon e raised to 2. So we got all the three integrals of equation. So result is finally here. So we have three integral results. So all the three integral result of right hand side of equation we need to simplify. So 1 upon 9. So first result of your first integral 2 pi I upon e raised to 2, and third integral result, and the middle one, the second one I have simplified. So we have to simplify here. So it will become minus 2 upon 9 pi I upon e raised to 2 minus 4 upon 3 pi I upon e raised to 2 plus 2 upon 9 pi I upon e raised to 4. So e raised to 4, but here we have upon divided by e raised to 2, e raised to 2. So these are the like terms. So I can, if you simplify, so pi I upon e raised to 2 is common from both these two. So minus 2 upon 9 and minus 4 upon 3 will become minus 14 upon 9, and this plus times 2 upon 9 pi I e raised to 4 as it is. So therefore, so take common 2 upon 9 pi I will get minus 7 upon e raised to 2 plus e raised to 4, or pi I upon 9, you arrange e raised to 4 first minus 7 upon e raised to 2. So this is the final solution here. Next example, evaluate e raised to pi z upon z 2z minus I raised to 3 dz, where C is the circle of mod z is equal to 1. Remember, if this is a point or pole, I can say if pole raised to any power is coming, at that time always we have to apply generalized Cauchy's integral formula. So here, so first we need to simplify. Always the coefficient of z will be always 1. So we need to make it a coefficient as 1 first. So here you take 2 common. So if you take 2 common, it will become z minus I upon 2 and bracket whole cube as it is. Again you separate it, 2 cube which will be 8, and this bracket cube as it is into dz. Now it is simplified form. So here you can find that the pole value is, that is a value is what here, I upon 2, which means you neglect I and consider as 1 upon 2. So 1 upon 2 is what here, inside before 1, or I can say that 1 is greater than 1 upon 2. So therefore we can say that inside the circle. So if it is inside the circle, we can apply the generalized Cauchy's integral formula. So therefore it is given by integration of f of z divided by z minus a raised to n plus 1 of dz is equal to 2 pi I upon n factorial f raised to n upon a. Now on simplification, so before simplifying, see that the values of a is 1 upon 2 and n value is 2, because here they have, it is raised to 3 means 3 can be written as what here n 2 plus 1. So the value of n will be out here 2. So on simplification, so n is 2 means here n 2 dashes will come. 2 dashes stand for what here double differentiation. So f of z is e raised to pi I, that is numerator part of the given question. And if you differentiate e raised to pi z one time, it will become pi times e raised to pi z, and if you differentiate this one more time, it will become pi square into e raised to pi z. So on simplification, apply these values. So 2 pi I upon 2 factorial, because here we need to simplify, n is 2 factorial, f double dash of a value, a is I upon 2. But what is f double dash of z? We know here. So here you need to apply the value of z as I upon 2. So I applied. So pi this 2 pi I upon 2 as it is. So here in this value you need to apply in f double dash of z. So it will become pi square, this pi square as it is, e raised to pi of, in place of z you replace I upon z. So on simplification, 2 and 2 get cancelled, pi I left, pi square into e raised to I times pi upon 2. But so the question having what here, this is our given required question. So we need 1 upon 8 is missing here. So multiply 1 upon 8 on both the side. We get 1 upon 8 into integration of e raised to pi z upon z minus I upon 2 cube into dz is equal to 1 upon 8 pi cube I into e raised to I pi by 2. You club it, pi I pi cube upon 8, and you apply e raised to I times pi by 2 can be written as cos pi by 2 plus I times sin pi by 2 using complex result. So but cos pi by 2 is 0 and sin pi by 2 is 1. So 0 plus I will become I, that this I and this I will become I square. Okay, so pi cube by 8, but I square is nothing but minus sign.